Hello, ladies and gentlemen. Today we're going to be taking a look at some review from Algebra 1 involving radicals. So we're going to need some rad algebra skills for our next chapter and the next semester. So we're going to take a look at a few days of that review before we just dive right in. You're going to need your notes. Calculator is especially handy, and pen or pencil. And kind of follow along and take good notes today, and I'll clue you in on the important things that you need to write down. First thing to write in your notes is square roots. We're going to be dealing with these things called radicals, and it's important to remember what a radical is. This symbol right here, that's the radical sign. A lot of times we read it as square root. You'll learn in later math classes that that can be a cube root, a fourth root, or whatnot. But for right now, that's our radical symbol, and it'll be square roots. The number underneath, or variable in this case underneath, that's called the radicand. So we'll be dealing with those numbers today as we go about simplifying square roots. So we're going to be working with radicals or square roots that look like this. So the square root of 49, the square root of 64, and even the square root of things like 20 or 12. What if the radical answer is a decimal? Well, to be most accurate, we will not write decimal answers, but we're going to simplify the radical instead. So while maybe you can type into your calculator the square root of 8 is 2.82 approximately, for our work to come, we want to make sure that we keep our answer very accurate. And rounding answers does not make them accurate, even if we write every single decimal value that we see on our calculator screen. If we're going to get into multi-step problems, we're going to want to avoid rounding until it asks me to do so at the very end, if it does. So we're not going to be writing decimal answers. Instead, we're going to simplify them. Here's another thing I would get down in your notes. Perfect squares. You should remember back to what perfect square numbers are. For example, to generate the list, you basically ask yourself what the square of every number is. So like 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared, 11 times 11 is 121, 144 for 12, 169 for 13, 196 for 14, and 225. Most of the time we'll stick under 225 here as we're doing our work. So these numbers that you've written right here, this column, and this column, these are perfect squares. Perfect squares are numbers that if you take the square root of them, they become okay integer values, whole number values here in our case. So if I did the square root of 144, I would get a 12. These perfect square numbers are going to be key to us as we go about simplifying radicals or simplifying square roots. So this is the first example you need to get in your notes. How do we simplify radicals without writing a decimal? You did this last year, but the key idea is you need to know your perfect squares. So if I have to simplify the square root of 45, that does not mean you go into your calculator and write the decimal. It means you ask yourself, if I had to break apart 45 into something times something, both of them underneath little square root signs, what numbers would I choose? One of those numbers needs to be from our perfect square list. So if we look back at that list, any of these red numbers, which one of them, or what's the biggest one that would divide out of 49? The answer is 9. 9 times 5 makes 45. So if I was going to take the square root and simplify it, I would make sure that I choose one number from my perfect square list. And that's where the 9 comes from. Since 9 times 5 is 45, I'm going to choose the 9 out of the perfect square list. And now I can simplify this because the square root of 9 is just 3, and the square root of 5 I'm just going to leave alone. So the simplified value for the square root of 45 is 3 square roots of 5. Let's do another one. Example 2, simplify. Square root of 50. So again, we're going to split the 50 apart into two things. One number has to come from the perfect square list. So if I ask myself which of those perfect squares divides out of 50 evenly, the answer is 25. 25 times 2 is the same thing as 50. And I'm liking the fact that I chose 25 because that number has a nice square root. The square root of 25 is just 5. The square root of 2 is irrational, so it does not have a square root, so I'm going to leave him alone. 5 square roots of 2 is my simplified answer. And one more here. How about 125? Again, looking through my perfect square list, which one of the numbers from my perfect square list would divide out of 125 evenly? The answer, 25 again. 25 times 5 makes 125. The square root of 25 is 5. The square root of 5 doesn't have one, and it's irrational. Here we go. Final answer. 5 square roots of 5. And last but not least, your last example. So we need to simplify 5 square roots of 32. So if we take a look at 5 square roots of 32, the thing you want to focus on is this radical here, and we're going to break him apart first. The square root of 32, let's continue doing what we're doing. Which of those perfect square numbers would divide out of 32 evenly? And you have a couple options here. Both 4 and 32 divides by 16 as well. Well, I think I want to choose the highest perfect square number I can to break this thing apart. It's like when you're simplifying fractions, you want to divide out the biggest number possible so you don't have to go through as many steps. So I'm going to use the 16. 16 times 2 makes 32. If I take the square root of 16, I get 4. The square root of 2, I don't know, so I'm going to leave it alone. And remember that 5 that was hanging out in front? He's going to plop right down next to that 4. Now that does not become 5, 4, 54 square roots of 2. It becomes a multiplication there, okay? There's no plus sign there. When there's no symbol like 3x, it means we multiply. So this is 5 times 4, making 20 square roots of 2. Here is my final simplified answer for 5 square roots of 2. Further simplified becomes 20 square roots of 2. Okay, that's our final example. So we're going to be taking some time today to practice what simplifying square roots should look like so we can get this process down and use it as we proceed here in the next semester. Thank you for taking good notes.